Hello and welcome to my channel. So let's work on today's daily challenging question. 994, rooting oranges. You are given a m times n grid, then each cell can have a value of 0, then it's an empty cell. And if its value is 1, then it's fresh orange. If value is 2, it's a rotten orange. So every minute, a fresh orange that is four directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So the example one grid is the only the this cell is a rotten orange, other is either fresh or empty. So the minute one, it go to the right and the down, so that this two also got rotten. Then it further expand to the next round, next layer. Then until the minute 4, everything is rotten. So the output is 4. And the grid length is between 1 and 10, so it's quite small. There are only 100, maximum 100 cells. So the question is, by looking at the question, it's kind of clearly that we can use the BFS to solve the question. So the BFS time complex is O of n, and the space is also O of n. We need to use a Q. So maybe so what we can do is firstly add all rotten cells to the queue. Then we can do the BFS, like as long as the queue is not empty, then we continue. There is another condition, is that we need to keep the count of the fresh orange. So do BFS until there is no fresh orange or queue is empty. And also we need to, in the BFS, we can keep count of the steps. Here the steps is minutes. So then in our end, we just output the minutes. Yeah, so this is the thought process. Let's work on the question. So firstly, we can get m and n. Also, we can define a directional array. So we use that to get a full direction. So m is a grid dot length, and n is a grid 0 dot length. Yeah, as I said earlier, yeah, we need to count the how many fresh oranges are in the grid. Oh yeah, and also yeah, there is a special case if the count is the fresh orange is already 0, then we can return 0. Yeah, so if grid ij is 1, yeah, and also we can initialize the queue. So the queue is using a 2D using an array as an element. So So that when we're doing this step, doing the count, we can also add those non-rotten, like rotten ones, to the queue. So this is a fresh, and then if it's a 2, right, the value is 2, it means rotten. Okay. Yeah, so value is 2, if value is 2, we add to the queue. If value is a 1, then we increment the count. Then here we can do a check. If the count is 0, means nothing is fresh, just return 0. Then otherwise we start doing the BFS. So if the queue is not empty, and count is larger than 0, then we can also we need to keep a count of minutes. Minutes, which is the output that we need to return. So then we can get the queue size, and we can iterate. So in this we are going to do is we get a current from the queue. We just pull it from queue, and then we get it R and C. So then we can use the 4-directional array. The array we used for the to get the 4-direction neighbor. So if so this is we get the R1 and the C1. Then we want to also define a function to check if the coordinate is in area. So yeah. So if is in area and if it's not in area, we need to continue. Or like the grid R1 C1 is not a 1. It's not a fresh orange, so we continue. Otherwise, we will mark this grid as this cell as 2, so it means it's rotten. Then also we add to the queue. Yeah, and also we need to increment the minutes. So the increment minutes here. So then we return minutes. So yeah, I think. Oh yeah, another thing, very important thing I forgot is I need to decrement the count, so that the fresh orange has a -1. So let's check. Okay. So the example 2, And oh yeah, another thing is that we need to return -1. So if yeah, so if the queue is still not empty, when the counter is 0, if the counter is not 0, if counter is 0, then we return minutes. If the counter is larger than 0, then we return -1, which means we cannot make all the orange fresh. Yeah, and then last example here, 02, I think it should work because no orange is fresh here. So yeah, so this yeah, you can see that it's a 2 millisecond and 97%. So it's pretty good. So let me know if you have any questions in the comment. So if yeah, otherwise see you next time. Thank you for watching. Bye.